Hey guys, in this lesson we would understand unit circle and special triangles in pi radian units. It is assumed that from the previous grades you already know what is a unit circle and what are its applications, as well as what are special triangles. However, the unit circle and special triangles in the previous grade were done in degrees, but in this course it will be done in pi radians. In case you need to refresh your memory, you can visit our playlist Introduction to Trigonometric Functions in APS Education Math and Science video channel, where the basics of the unit circle and special triangles is explained. Here in this lesson, we would quickly understand unit circle and special triangles along with the cast rule in pi radians in order to use these for application problems. We know these are the special triangles and the values in degrees that is already known from previous grades, and we can use these special triangles to find out sine, cosine and tangent ratios for angle 30, 45 and 60 degrees. We can rewrite these special triangles in pi radians. The side length values would not change. The only difference would be that these degrees would be written in pi radian angle. We know in order to change 30 degrees to pi radians, we have to divide it by 180 multiplied by pi. This we learned in lesson 1. We have to reduce this fraction down into lowest terms, and this would give us 1 over 6 pi radians, or we can simply write it as pi by 6 radians. So 30 degrees can be written as pi by 6 radians. Similarly, 45 degrees can be converted to radians as well. So it will be 45 divided by 180 multiplied by pi. When we reduce this down to lowest terms, it would give us 1 over 4. So we can write it as pi by 4 radians. So we can change 45 degrees and write it as pi by 4 radians on the second triangle. Similarly, we can solve for 60 degrees. And 60 degrees will be 60 divided by 180 times pi, and that would give us pi by 3 radians. So whenever we are given 30 degrees, that can be written as pi by 6 radians. 45 degrees is same as pi by 4 radians. 60 degrees is same as pi by 3 radians. Let's use these radian measures and redraw the special triangles. We know this angle is 90 degrees, and 90 degree using the same method can be written as pi by 2 in radians. 30 degrees is pi by 6, so this is pi by 6. 60 degrees is pi by 3, so pi by 6 opposite side is 1. Pi by 3 opposite side is 3. Pi by 2 opposite side is 2. Pi by 4 opposite side is 1. Pi by 4 opposite side is 1. And pi by 2 opposite side is root 2. That's for the second triangle. We know we can use these special triangles to solve for SOHCAHTOA. So if we want to find out sine pi by 6, because now angle is going to be in radians, so we would be writing along with these ratios the angle in radians. So sine pi by 6 is opposite over hypotenuse. For pi by 6, opposite side is 1, hypotenuse is 2. This can be written as 1 over 2. Similarly, we can solve for any other trigonometric ratios for these given angles, pi by 6, pi by 3, pi by 4, without the need to use a calculator. Next we have is the unit circle. It's the circle with radius 1 unit. Before going over the unit circle, let's quickly go over the basic definitions of different terms that will be used when we are describing the unit circle. The first definition is principal axis. It is the line or arm that lies on positive x-axis. Next is the terminal arm. Principal axis can also be called principal arm. Terminal arm is the line or the arm that is going to rotate around in a circle. Next term is principal angle. Principal angle is the angle that is formed between the terminal arm and the principal arm, and it is represented as theta. Next term we will be using is related acute angle. Related acute angle will be represented as beta, and this is the angle formed between the terminal arm and the nearest x-axis. So let's see how these terms are going to be used on the unit circle. We know principal arm is the arm that lies on the positive x-axis. So if we divide this unit circle into 4 quadrants using a coordinate grid, then this is the positive x-axis, this is positive y-axis, negative x-axis, and this is negative y-axis. Principal arm lies on the positive x-axis, so this yellow line is going to be called principal arm. Let's mark it with PA. Terminal arm is the arm that is going to go around the circle. So let's say if terminal arm is here, then the angle formed between the terminal arm and the principal arm is called the principal angle, represented with theta. Now, if we are in the first quadrant, that means the principal arm definitely is going to be on the positive x-axis, but the terminal arm is also going to be on the first quadrant. So the angle that forms between the terminal arm and the principal arm is theta, called principal angle. Now, what is this related acute angle? Related acute angle is the angle that is formed between the terminal arm and the nearest x-axis. The nearest x-axis in the first quadrant is the positive x-axis. Therefore, in the first quadrant, the principal angle is also called the related acute angle. Since related acute angle is represented with beta, therefore in the first quadrant we can say theta is equal to beta or beta is equal to theta. Now, if the terminal arm is in the second quadrant, principal arm always on the positive x-axis, then theta is going to be the angle between the principal arm and the terminal arm. The direction that we go or we draw theta is always from the principal arm to terminal arm, and that is counterclockwise direction. Because beta is the angle between the terminal arm and the nearest x-axis, in the second quadrant the nearest x-axis is the negative x-axis, so beta is going to be the angle between the terminal arm and the negative x-axis. If we want to write on the relationship between theta and beta, that would be theta equal to, because this full angle is 180 degrees, or 180 degrees when written in pi radians is actually pi radians itself. So we can say theta is equal to pi minus beta. And if we want to solve, or if we want to write in terms of beta, that would be pi minus theta. So beta is pi angle minus theta. If the terminal arm is in the third quadrant, then angle always goes from the principal arm to terminal arm, and the angle is called principal angle theta. So theta will be drawn this way. The angle formed between the terminal arm and the nearest x-axis, which is again negative x-axis, is called beta. So the relationship that we can write down is theta is equal to, because theta is this entire angle, that is the semicircular pi radians plus beta. So we would write on theta is equal to pi plus beta. And if we want to solve for beta, that would be theta minus beta. In the questions, we can be asked either to find out theta or beta. So all we have to do is just have to know the relationship in different quadrants. If terminal arm is in the fourth quadrant, we're not going to go this way. We are always going to go from the principal arm to terminal arm in counterclockwise direction. So this is theta. Beta is the angle between the terminal arm and the nearest x-axis, that is now the positive x-axis. For beta, direction does not matter. So this is beta. We can write on theta as the entire circle minus beta. Entire circle is 360 degrees or 2 pi radians. So it will be 2 pi minus beta. And beta will be equal to 2 pi minus theta. This is how we represent theta and betas in different quadrants. Once we know these relationships, we can apply these relationships to any type of related acute angle or principal angle questions. Now, after understanding related acute angle and principal angle, let's quickly go over the unit circle in details. We know this is the principal arm, this is the terminal arm, and this is the principal angle. The only principal angles that we will be interested in are the ones that will be lying on the special triangles, and 0 and 90 degrees, or 0 and pi by 2 radians. So that means we will be interested in 0, pi by 6, pi by 4, pi by 3, and pi by 2 radian angles. Now, if we are in the first quadrant, then terminal arm would lie on the principal arm. It will be forming 0 radian angle, and that would look like this. So principal and terminal arm are lying on top of each other, that forms 0 radian angle. Wherever the terminal arm is going to touch the unit circle, that point is going to be represented with x and y coordinates. Because it's a unit circle and we know the radius of this circle is 1 unit, so the coordinates of this point would be 1, 0. Because the x value is 1 and the y value is 0. Always remember the x value represents cosine of the angle that is formed between the principal and the terminal arm, and the y value represents the sine of the angle that is formed between the terminal arm and the principal arm. In this case, the angle is 0, so cos 0 is 1, sine 0 is 0. When the terminal arm subtends an angle of pi by 6 radians, then the point here would have x coordinate √3/2 and y coordinate 1/2. Where do we get these x and y coordinates? Because I told you x and y coordinates are same as the cosine and sine values. So that means √3/2 is going to be cosine pi by 6 that we can get from special triangles, and 1/2 is same as sine pi by 6. That also we can get from special triangles. Next angle is 45 degrees or pi by 4. The point it would touch on the unit circle is going to have x coordinate as cos pi by 4 and y coordinate as sine pi by 4. Next we have is pi by 3, which is 60 degrees. That would be represented as cos pi by 3, sine pi by 3. In order to get the values, we can use special triangles because pi by 4, pi by 3, they all lie on the special triangles. Next, the terminal arm when reaches or when subtends an angle of 90 degrees with the principal arm, then it reaches on the positive y-axis, and the coordinates are going to be, we can see here, x is 0 and y is 1. Therefore, we can say cos pi by 2 is 0 and sine pi by 2 is 1 because this angle is pi by 2 and x represents cosine of that angle and y represents sine of that angle. This is about the first quadrant. If the terminal arm crosses the first quadrant and reaches the second quadrant, that is if it comes here, then the next angle that we are interested is this angle, and that is 2/3 pi. Now, why are we interested in this particular angle? Because the related acute angle for this angle is going to be equal to pi/3, and that is same as what we get in the first quadrant. So we will always be interested in the angles that give the related acute angles same as pi by 3, pi by 4, pi by 6. If we want to check that the related acute angle is pi by 3 or not, because we're in the second quadrant, we know the rule says related acute angle is pi minus theta. So beta will be equal to pi minus theta, and theta is 2/3 pi. In order to solve this, because this is a fraction, we would multiply and divide by 3. So we would get 3 pi/3 minus 2 pi/3, and that would give us pi/3. So we got the related acute angle as pi/3. Next angle we would be interested is the one that is going to give us pi by 4 related acute angle, and the next one should give us pi by 6 related acute angle. The reason we are going with the same related acute angles is for the same related acute angles, and no matter which quadrant we are in, first, second, third or fourth, we would get the same cosine and sine ratios. So this point would be same as cosine pi by 3 for x coordinate and sine pi by 3 for y coordinate. Now we notice here that the x coordinate in the second quadrant is a negative x. Therefore, all the cosine values are going to be negative, and all the sine values, as they represent the y coordinate, are going to be positive. That's the only difference between the first and the second quadrant. So here we would have negative cosine pi by 4, and here we would have positive sine pi by 4. This point coordinates will be negative cosine pi by 6 and sine pi by 6. So if this value is √3/2, 1/2, here it would be negative √3/2, 1/2. If cosine pi by 4 is 1/√2 and sine pi by 4 is 1/√2, here it would be negative 1/√2, 1/√2, and so on. Now remember one more thing here, that tan of an angle is represented as sine of the angle divided by cos of the angle. So if we want to find out tan pi by 6 value, we can take sine pi by 6 value, which is 1/2, divided by cos pi by 6 value. And this can be applied to any other angle as well. Let's talk about the third quadrant now. If the terminal arm is in the third quadrant, then the angles we are interested in is again that is going to form pi by 6, pi by 4 and pi by 3 related acute angles. So if this is pi by 6, then this is the terminal arm where it will land at, and this point would be negative cosine pi by 6 comma negative sine pi by 6, because in the third quadrant both x and y axes are negative. Next we will be interested as in pi by 4 related acute angle. So that would give us the point represented with coordinates negative cosine pi by 4, negative sine pi by 4. Next is going to be negative cosine pi by 3 and negative sine pi by 3. If the terminal arm comes back to the fourth quadrant, then in the fourth quadrant we have a positive x and a negative y to deal with. The related acute angle here will be pi by 6. So it will be cosine pi by 6 with positive sign, because cosine represents the x coordinate. Sine will be with the negative sign, so it will be negative sine pi by 6. This is positive cosine pi by 4, negative sine pi by 4. This is positive cosine pi by 3. This is negative sine pi by 3. After looking at all this, we can write down the cast rule. So cast rule says this is CAST. First quadrant is all positive. So cos value is positive, sine value is positive. And because sine and cos both are positive, positive divided by positive means tan is also positive. Therefore, the first quadrant is everything positive. When we are in the second quadrant, only sine and its reciprocal is going to be positive. As we notice here, sine values are all positive, whereas cos values are all negative. If we want to find out the tan value, it will be positive over negative. That will give us tan negative. So only sine values are positive, and the reciprocal of sine, that is cosecant, is going to be positive in the second quadrant. If we're in the third quadrant, then both cos and sine are negative. However, tan is sine over cos. So if sine is negative, cos is negative, tan is going to be positive. Therefore, it is tan positive in the third quadrant. Reciprocal of tan is cot. So cot is also going to be positive. When we come to the fourth quadrant, because cos is represented by the x values and x coordinate is positive, so fourth quadrant is positive for cosine values, and the reciprocal of cosine is secant. Therefore, cos values are positive and secant values are positive in the fourth quadrant. And this is what is called the cast rule. We would be using all of these rules that we have learned in this lessons to apply them on the following lessons in order to understand these rules better.